Welcome to another data science deep dive on the data science non-technical track. In the following presentation, Sivan, Aldor-Noiman, head of data science and data engineering, and Nandika, Donthi, data engineer of active learning at both from Wellio, speak about how machine learning-based data products life cycles do not necessarily follow the same development paths as most conventional products do. These data products bear inherent risks and rewards that are sometimes hard to quantify and even recognize in advance. They talk about how in the era filled with countless AI and machine learning, solutions are not always the answer. Enjoy.
So thanks, Julia, for giving us the opportunity to talk about what we're doing in Wellio. So Wellio is a food technology company, which Nandika and I are part of. We're part of the machine learning platform team. What we're going to do is a little bit tell you about Wellio so you have context on what we're doing in the food space, and then really share with you our learnings around how we develop data products. We've learned a lot of things through trying, so hopefully you'll find our learnings valuable for yourselves as well when you're trying to develop data products. So here we go. So if you look at kind of the food system, a lot of emphasis is being given to how do we feed billions of people, and this problem is really serious. The prediction is that by 2050 we'll have 10 billion people, which is an increase of almost 3 billion people, extra people from where we are today. So there's a growing population issue. To make that things harder, we have over time land usage for agriculture purposes is going down. So there's less land to produce food. There's more demand to produce food. But there's also the kink in the world, which is the climate is changing. It's much harder to grow things at a sustainable rate. So in food system, one of the major problems is feeding people. How do we feed a lot of people in the next few years? And that is a very serious problem. However, setting up the problem this way really doesn't do justice to another constraint, which is it's not enough to feed people. You need people to eat good food, nourishing food. And I think that's a very important constraint. It's not, we can't grow anything. Well, we can grow whatever we can, but in terms of actually helping people manage the food that they're eating, that's a constraint that I think the food world is looking at, especially because there's a lot more prevalence of diabetes in the world these days, a lot more people that are struggling with obesity. There's actually more people with malnutrition as well. So yeah, we need to feed people, but actually we really need to also really think about nourishing them, making sure that what they eat is not junk food, making sure that what they eat actually helps their body become stronger and healthier. And I think that's sort of where Wellio started. This concept of the founders moved from the agriculture world, where the emphasis really is around feeding people, to the food technology space, where the emphasis is really about nourishing people. And there's a lot of ways to sort of try to solve this problem of nourishing people. The Wellio way of doing it is through helping them cook at home. So when people start cooking at home, they really start understanding what they put in their foods. They start to question what comes into their food. And just by the mere action of cooking at home, they get more, they start to nourish themselves better. And so the Wellio solution to this, nourishing billions of people, is how do we create personalized meals for people so that how do we help them cook at home? How do we assist them through the cooking process and the planning process? And ultimately, how do we nudge them and modify their behavior so that they really adapt a healthier food consumption lifestyle? So that's sort of what Wellio is trying to do. Maybe to bring in the machine learning world into it a bit. There's lots of companies, again, that are trying to help people eat better at home. There's all sorts of companies that send you in advance the food and you just have to assemble it, things like that. I think the way we approach it is we think, okay, well, someone comes in, they want taco for dinner, but they have all these constraints and there's all sorts of knowledge that the culinary world has. So a person might want to cook for 4 people. So that's a constraint for the system. They may have gluten allergy. They may have high cholesterol. So they have all these health goals and constraints that they bring into this moment of they want to cook something at home. But the culinary space also thinks about, okay, well, they have these constraints and they want to cook the tacos, but maybe they should also pair it with like some side, like a salad. Maybe they can substitute some of the gluten products with non-gluten products. And maybe another interesting twist to the story is they may not have everything in that original recipe for tacos. They might have some things that at home that could be used as substitutions. So if you build a good machine learning platform, it can take all these constraints and all this culinary space understanding and bring it together and say, okay, well, the best recommendation is a spicy shrimp tacos. Because that way you can utilize everything you have at home. You can pair it with some side dish that's good. You can substitute with the gluten products, and you can actually make it for 4 people. So we're thinking a scalable way to address all these constraints is through machine learning solutions. Deeper dive, one more step is the data that you can think about devising a platform that you really teach the culinary art to. And then can take all this information and bring it together to the consumers. This teachable machine learning platform takes into consideration recipes. Recipes are semi-structured documents. What our team spends a lot of the time, and Nandika's team spends a lot of time figuring out, is how to utilize this semi-structured documents to produce useful data products. So for example, one data product is the cuisine type. One data product could be the course type. One data product could be the ingredient terms. What are the ingredients terms in this document? So to build this platform, it's just not a single machine learning model. It is a multiple machine learning models that are packaged into data products. And our platform brings together all these different data products. And then with the feedback it gets from our consumers, we can then create personalized food and diet recommendations. And that's sort of the cycle that we are continuing to improve and build in our products. So really the vision, right? This is not where we are, but this is where we're going as a company, is to have this intelligent platform then can support the following type of experience. The user comes in and says, well, I'll pick this pork and bok choy stir fry, but I would like to customize this recipe for me. And the system really knows this customer and knows that sometimes they they prefer vegetarian. They're kind of what we call a flexitarian consumer. Most of the time they want vegetarian. Sometimes they are okay eating meat, for example. But the system knows this person and says, okay, sometimes they want to make vegetarians. Actually, sometimes they prefer batch cooking. So maybe we can optimize this recipe for batch cooking. Or sometimes they really seem to prefer mushroom over red peppers. So the system brings a list of options for the user, and the user says, well, today I feel like I want to make this as a vegetarian. And then what the system will do is rewrite the entire recipe, whether it's small things like the title, so you see the pork changed with tofu, but also we'll rewrite the ingredient list, we'll rewrite the preparation steps. Obviously, cooking tofu is not the same as cooking pork, so there needs to be modification to the actual cooking steps. So this platform will regenerate the recipe based on user preferences and constraints to really try to keep the recipe taste and texture as close as possible to the original recipe taste and texture. So that's the ultimate vision, right? But, we're not there yet. We're building data products one step at a time. And so today we're going to walk you through one of the data products, and that data product is our course classifier. And what we really want to do is just walk you through the steps that we had to take in order to enhance this data product. And then Nandika will go through all the steps. I'll just do the easy part, which is I'll share with you the business problem we had as a team. And then Nandika will take all the hard questions of like, how did we actually do that? So let me just set up the stage for Nandika. So the first thing that the team had to really understand is what is the business problem we're trying to solve. So the way it happened is we already had a course classifier data product that took a recipe and told us which course it's associated with. So for example, it would get this pork bok choy and it would say it's a main, or it would get another recipe and it would say it's a beverage. So it knew how to classify a specific recipe to the most likely course. However, we got some product feedback after using this product for a while in our system. The first one was the precision is not very good. So, for example, we would surface we would allow the client to filter, for example, for only main. However, they could still see other types of courses, obviously misclassified, but they would sometimes see beverages, and sometimes they would see other things in there like desserts. So it wasn't, we knew we didn't have, we knew we had errors. So that's one thing that we got feedback about this data product. The other one was from our culinary expert, who kept telling us that, in the culinary world, it's not that rigid. It's not like a recipe belongs to a main and will never be anything else. It could be some recipes, actually, depending on the portions of ingredients, they could be kind of like more a continuum. They could be an appetizer, or they can be a side, or they can be a main. It really just depends on the portions. So she gave us the feedback that the model is too rigid. And then the last one was an ask for, hey, we need some new labels around dessert, for example. People are asking for it and we're not exposing it. And in the original data product, we had dessert, but the precision was so low that we did not want to expose it. So we really had to create new types of labels as well. So if we kind of take this product feedback and the data product as it was, the ask from Nandika's team was, hey, improve the precision of the specific courses that we already have, enable recipes to have multiple courses associated with it, and then also expand the product label space so that we can support new labels. So that we have a definition for the problem, and we kind of understand what we need to get to. I think the next step that the team had to really figure out is the risks. And Nandika will go through a lot of the details of how her team and she de-risked some of these risks, but just at a high level to explain the risk that we had to really, and we always have to be honest, and any data product, we have to assess our data risks, model risks, and operational risks. The data risks are really understanding new data sources. So as I said, we had a data product already, so we did have a past data associated with it. But now we've already accumulated over time more data. So the question is, how does this new data source quality and volume compare to the old one? How does it stand by itself? There's model risk that the team had to sort of figure out how to de-risk and deal with. For example, can we take a more novel modeling approach than the old data product took? How does that compare with our platform requirements? We did, when we first deployed this data product, I think it was 2.5 years ago. And as you can imagine, as a data scientist and a data engineer and machine learning engineer, versioning of all of the packages in Python have been advanced a lot. So, no, it's probably not compatible with the old stuff. So assessing those risks and understanding how to deal with them. And then obviously the operational risks, like we already have an existing data pipeline. So how does this new data product fit into there? How do we make it fit into there? How do we integrate with live clients? We already have people using this data product. So we can't just like switcheroo everything and just expect that those clients will not have an impact, right? We must have somehow de-risk negative impact of a data product. And then there's the normal software constraints, like there's latency associated with this data product and services. So we have to be able to manage those constraints as well. So what Nandika is going to do is she's going to walk through the different steps that we had to take to uncover these risks and also actually deal with these risks. So Nandika, take it away.
Thanks, Sivan. So the second step in our journey and this data product development framework that we have is a discovery process. And to ultimately answer the question, can we deliver this data product based on all the risks that Sivan had mentioned? More and more, we've learned that in the AI space, great ML systems are really able to blend domain expertise and expert intuition. And this is also a principle that we deeply value at Wellio. So for this, user-guided data and product discovery and EDA are not only essential in building this intuition, but also in mitigating missteps and risks later down the line. So the first part of this process was understanding our various users and their needs and translating this into data needs and model development goals. So to do this, we collaborated with our product managers, our product designers, and various stakeholders on the platform side to help us clearly define who is consuming this data product, how have their needs evolved, what happens if a recipe has a specific course label, how does that affect the recipes that are exposed. So on the product side, we had our home chefs who wanted to be able to search and prepare recipes of additional courses. We had our future external platform users who needed recipes to be annotated with all possible courses. And we had our internal platform users who wanted all of the above, but also better precision in classes that we had already exposed. So at a high level, we knew that we needed a multi-label model and not a multi-class model like Sivan had mentioned. But this discovery process allowed us to further refine our scope, refine our reward function, which features we were going to use, and identify potential pitfalls. So we were able to begin to recognize second-order effects of our potential outputs or the consequences of a certain prediction. So in this case, it was how certain class predictions or course labels would affect our users through the recipes that we exposed via browsing or recommendation. These user needs then began to really easily translate into data needs and helped us identify the gaps between what we had and what we needed and how to go from this multi-class data set to a multi-labeled data set. So for example, we knew that we needed a data set with key recipe features like title, ingredient, description, etc. And we needed more multi-labeled recipe data, especially in the classes that we were currently poor at predicting. We also knew that we needed additional data sets surrounding user activity to figure out which recipes were most popular, which ones were most discoverable to use in model testing later down the line to ensure that we were maintaining quality in what we were already exposing. So from there, we began to follow standard model development steps. So feature engineering, experimenting with different model architectures and training things. So some secondary goals for this discovery were to take leaps in our experimentation process, to try out different model architectures and training techniques, to see if we could use and integrate NLP models like BERT, and ultimately improve our existing infrastructure. So once we had determined that we could deliver this data product, we began to plan for delivery, essentially turning these key findings from our discovery process into metrics. So to figure out a timeline and key milestones we needed to reach, we started with a very simple statement, or a very simple group of statements about what a successful outcome would look like in human terms. And then we translated this into a development goal, making sure that we were considering countermetrics. So for example, making sure that we were not reducing precision in the classes or the recipe course labels that we already had. And really trying to understand how false positives or false negatives would affect our products to ensure that we weren't over-optimizing for classes that weren't really used yet. We set a timeline around this metric and hard deadlines, making sure that we had a plan to revert to developing a simple model if we weren't meeting these metrics. So really sitting down and saying, we're going to spend 3 days on plan A before we try plan B. And really making sure that was defined, because this delivery process can otherwise be endless. Something that would have been important to also do at this stage, which we later realized, was really working in parallel with the ML engineering and ops side of this process to understand the technical constraints or bounds of what we could deploy, which constraints were more rigid and which constraints were more relaxed than others. So for example, understanding if we could use certain packages or libraries, what formats were necessary for exporting the model, can we actually get this model out of the training algorithm? And generally working with the ML engineers or ops or DevOps engineers to make sure that the development environment and the serving environment were as similar as possible, and letting them know, or letting whoever it is know, hey, I'm trying to deploy a model of this type. Can you test the infrastructure and can you see if it works without the actual fully trained model in place? Since this was an existing data product, we also had some other considerations. We had to develop an implementation plan to integrate the product into our recipe representation, various workflows and data pipelines, and really ensure backwards compatibility. So once we had fully developed the model, this led us to the actual delivery process itself. So in some organizations, this could mean a handoff of sorts between data scientist, data engineer, and ML or ops engineer. In other cases, it could be that these responsibilities are combined. But regardless, these are some things that we found that we had to consider for either role. So the first one being test everything. So test anything and everything possible. There were many questions I found that I wish I asked myself and consequently turned into very defined tests. So some of them being, is this tokenizer producing the expected output? Is this encoder producing the expected output? Does this lowercase function actually lowercase my input? So really testing every part of your pre-processing and post-processing steps, your feature engineering. Once you get to the post-processing side, does my model produce the same metrics in its exported form? If you're using third-party packages or libraries, do they produce the same output in the serving environment? Does this cache the way I want it to? Are there any dry violations? And while these seem like quite standard best practices for any software engineering process, with ML-based systems, the number of moving parts, the number of assets and processes to manage and test sort of explodes. So all of a sudden, you go from needing your traditional unit tests and integration tests to also needing data tests, ML infrastructure tests, SKU tests, model tests, and so on and so on. Another consideration is to evaluate model quality at different stages of delivery. So if you have different environments, making sure that your predictions are standard across your integration, staging, and production environments. Each one has different levels of traffic, different services, different interactions, and so the data product integration will also indubitably vary. One way to do this that we found helpful was to perform sort of ad hoc qualitative evaluation of common use cases. So taking those data sets around user activity that we found in the discovery process, turning them into inputs, and making sure that samples of the resulting ML output made sense. So of course, this depends on the data product you have and its variability. This may be easier in some cases than others, but this was a way that we were able to sort of understand and sort of predict what the users would see from an ML side. On a more ML ops, DevOps side, latency will always be a constraint, but this doesn't necessarily need to be a bounding one. So if your resulting model at this point is a complex model with hundreds of millions of parameters, it's going to get tricky. So perhaps you alleviate this issue by refining your service architecture. How can you get creative with how you scale? How can you take advantage of caching and batch processing? How can you use a GPU for online prediction? And if you can't, what can you do in lieu of this? If after you go through all of these steps and it's impossible to maintain the same level of service consistency, then go back to the data science process or go back to the data scientist, and maybe you can work together to slim the model down a bit, which is something we ended up doing, or figure out other options. The last thing I wanted to mention was documentation of development, documentation of feature sets, knowing who is creating and maintaining each feature column, and making sure that development is reproducible is something that we found extremely helpful in this step, and something that became even more important when building our model pipeline, like I'll talk about in the next step. We also plan in the future, in our future data product development, to create server-side A/B experiments to make sure that we're able to understand the impact of a new data product quantitatively. So this brings us to step 5. So at this point, we've deployed our data product and it's out in the wild. So now what? Fortunately or unfortunately for us, our work was not done. So beyond our standard monitoring of services and making sure that everything was up and running, keeping an eye on the training serving skew was especially important at this stage, and making sure that the distribution of predicted labels was equivalent or was very close to the distribution of observed labels. Something we also plan to do in the future with future data products is to formalize this process and implement really live data quality monitoring and dashboards around this. Something I read recently that stuck with me was that your model's accuracy will be at its best until you start using it. So of course, this is more directly relevant in some cases than others, but definitely applicable across the board with all data products and all organizations. In terms of maintenance and future development, being aware of concept drift and the change in relationships between input and output data over time was key, especially for us, since this was one of the initial reasons that we decided to enhance and redevelop the data product in the first place. In this situation, while our output is quite stationary, so a recipe that's a main course today in the food world will still be a main course years down the line, our input definitely varies over time. We regularly add thousands of recipes to our database of all different types and all different cuisines, so the input that the model sees and the ML system sees changes over time. Measuring and documenting undesirable data product behavior for future iterations was also extremely helpful. And we formalized this process by building an ML pipeline around our model. So this was a pipeline that identified blind spots or instances and classes where the model was currently performing poorly in, retrieved all of this, sent it for annotation, processed and combined all the new data, and retrained a new model and deployed it if it showed improvement over the existing one. There are many great open source frameworks out there like Kubeflow and MLflow that help in building pipelines like this. And if your data and model development steps are reproducible, this part becomes easier as well. Depending on your organization and resources available, monitoring and maintenance will vary, but it's definitely something that should be done, whether it's in a casual or a defined way.
Okay, step 6. So step 6 is the hardest of all steps. You have to actually define done. I think as people in the data science and machine learning space, it's very hard for us to let go because, well, there's always a way for us to tweak the model, to try out different model frameworks, things like that. And we don't necessarily know what the impact of those decisions will be on the data product quality. And so defining done was a very important part of the process and still is. The consideration for defining done is the business needs. Have you met them? And as Nandika so eloquently explained, yeah, we were able to meet the business needs with this iteration of the data product. So that's one side that was great. The other consideration is data availability. And that one, again, we used all the data that we could at that point. And so, no, there wasn't a mysterious data set that was left behind. And then obviously technology. Have you used, kind of the latest in this space of machine learning to try out with this data product? And the answer was, yeah, we used something pretty advanced, both from an infrastructure perspective and from a modeling perspective. So in these kind of considerations, we did do our best. Again, if you think about data product improvement curves, you can think about an S shape, and you can squish the S or you can stretch the S, but it's an S, which means over time you may invest more, but at some point the improvements become smaller and smaller and smaller. And that means that maybe the impact that data product can have on consumer side may not be as large and as impactful as one would wish. In our company, because a lot of things are new and we're a small company in the beginning in our data product cycle, this improvement to the product, adding the capability to multi-label, adding the capability of supporting new labels and improving precision made a big leap. So we're somewhere in the large gradient on the S. And so this cycle was a big improvement to our data product quality and capabilities. Have we reached the place where we can't improve anymore? Probably not. But in order for us to invest again in this data product enhancement, we would have to see new business needs. Maybe precision will, as Nandika said, there's new inputs, so maybe the precision will decrease over time. We need to fix that or anything like that, or new labels or new requirements that I can't think of, but maybe. Data. So we're letting it in the wild, but we're also accumulating new data as we're speaking. So we want to let it be for a little while and accumulate more data. And yeah, in the space of machine learning, things move really quickly. So in half a year, there might be a very cool new technology that we need to try out and see if it can improve the model vastly. So for now, we're happy with the improvement we made. We're going to let it go. So that was the last step to sort of decide, yeah, we're done for today. So kind of to summarize the learnings we've had and we're taking with us as we create more data products and we improve them is, as much as you can, do your homework in advance. Like take the risk assessment that we talked about, the operational, the data, the model. Those, if you can spend a few days really, looking into, those will pay dividends in weeks and months if you can do a good job in the beginning. So give yourself the few days to really do that work. As Nandika mentioned, collaborate with stakeholders. We're small, so we don't have a handoff between machine learners and data scientists or anything like that. But, speak to the DevOps team, talk to the product manager, talk to the clients. Their views can help shape the solution really quickly, actually. Early integration with environment, and I'll bring the test at the same time. So different environments have different data in them. And so, yes, as much as you can test it in different environments, that's better. As much as you can understand the impact in different environments, that's better. Testing even small functionality, just any software development, is good. It's true for data product development as well. And then it's a product. It's a data product, but it's a product, which means you have to monitor, you have to maintain it, just like any other digital product that the company produces. This is an actual product that the company produced. So yeah, monitoring and maintaining it. And that's it. That's what we wanted to share with you. Hopefully this was useful for you. And then Nandika and I are here. If you have any questions for us, we'll be happy to take them.
That was a presentation by Sivan Aldor-Noiman, Head of Data Science and Data Engineering at Wellio, and Nandika Donthi, Data Engineer and Active Learning at Wellio, who spoke about how data products bear inherent risks and rewards that are often difficult to quantify and even recognize in advance, and how building machine learning products is a lot different from actually building regular products when it comes to practice and deployment. If you'd like to watch more videos like this, you can subscribe to the Data Science Insider program. Link is found in the comments section. And you can also subscribe to the channel right below. Thanks.